Thank you very much, everyone, for joining and staying 20 some odd hours for Henrik to get this far, as he's done it I don't know how you keep doing these multiple times. I don't know if you've been around in IT operations and performance for many years like I have. You've seen this amazing little hashtag show up. It's fervent. It's hashtag O11Y, like accessibility, but it stands for observability. And it's not that it's finally showed up on my radar screen, because I made a lot of presumptions about observability, meaning this is something I already do. And truth be told, it is something I already do, but it's not something I actually talked about in the way that some of the industry thought leaders talked about it. So I wanted to give a presentation and a talk about a little bit of the research and some of the sort of newfound respect for what makes observability different, and how we can, from performance engineering, from that perspective, not just load testing or performance testing, but really from engineering a system and designing a system, what we need to think about in terms of being able to observe that control plane, if you will, across the entire system that we have. And that's what becomes observability. So I backed up, thinking about old stuff. I decided to back up a little bit and start with some analogies. I also wanted to go back, so I have some analogies to go through for what is observing performance. I also find it really helpful to talk about something by what it is not. So if I think about unobservable systems, and it was easier for me to relate to my own experience going, oh, I've been in those situations, so we'll talk about that. I want to talk about visibility being sort of the cornerstone of observability. And as you just saw with Martin and countless of the presentations over the last 24 hours or 20 hours, visibility is really the key piece. A flame graph is like an amazing visual that suddenly can be used across multiple disciplines and different roles. So we'll talk about engineering for visibility. And then the next step, which I find interesting, is sort of performance socialization, sort of socializing the idea around performance and how observability plays into that. So let's go back in time, if we will, and look a little bit at sort of the origins of something that's not observable or wasn't observable, but was equally dangerous. And that would be sort of a Model T Ford, which in its day was built later, maybe in the early 1900s. And it was built without a speedometer, meaning you didn't have any way to measure or observe through a gauge or some scientific mechanism how fast you were going. You were the whole origin of like flying blind comes from airplanes, but you're driving with your eyes closed as a metaphor. And so if you think about how important it was to be able to observe how fast you were going, well, back then there were hardly any stop signs, street signs. There were almost no signs, maybe a few signs, nothing standard. There were no lights, or there maybe was a traffic cop or something in busy places or things like that. But for the most part, it was like one step up from a horse and away you go. A horse doesn't have a speedometer, so why would a car have a speedometer? Cool. All right. So somebody, I believe there's a guy named Otto Schultz from Germany in the late 1800s that had eventually figured out through a magnetic mechanism to figure out sort of since the gears were rotating and you connected either to a wheel or to the transmission or the power take, where that would be, we invented a speedometer. And so now we could actually see how fast we were going. And of course, that same technology gave us a tachometer. We could see how many RPMs that little engine was running at, and we could see how fast we were going. So boom, we can observe now through some measurement. But even then, to some extent, how fast we were going was really only visible by the person's driving the car, the person in the passenger seat or the back seat. If you've ever been with people who are nervous in a car, they can't see how fast you're going. And of course, I remember like my grandparents, how fast you're going, Sonny? And it's just like, that's crazy. So we invented that, but it was also sort of wildly inaccurate the way we put where it connected, and the magnets would go bad, or suddenly it was like, oh, my speedometer is always 10 miles an hour faster than the actual car. So you figured out on certain cars. So depending on from one car to the next, to the next, to the next, it was really inaccurate. And you couldn't really know how fast you were actually going. And of course, back then, traffic police people they didn't have radars or anything like that to figure out how fast you were going. So it was really, really inaccurate, the early, even though it was observable to one person. Then we added sort of more accurate capability in sort of the digital. Now that we had electronic transmissions, we had electronics within the car that were growing up, computers, we could calculate what gear you were in based on how many RPMs as to what the revolution. Now, the thing that was goofy there is if you've ever been stuck in a snowstorm and you're pushing on the gas and the wheels are spinning, you're not actually going anywhere, but the speedometer says you're going like 90 miles an hour. Like the wheels are spinning. So again, wildly inaccurate, and we made it digital. We innovated all this. Like, oh well, we can monitor the revolutions per minute. We can put an instrumentation of how many turns are, but it still was like crazy inaccurate. And even though we digitized it, okay, great. Then we come up with GPS. Now we got consumer level GPS that we can put in a car. GPS allows us from an external vantage point to actually track where you are from a feet per second, and then do some estimation as to, all right, well, if you went from point A to point B in 10 minutes, you're probably going this fast or that fast. And of course, GPS is pretty accurate. It gets down to maybe within 20 feet or I think 10 feet more or less. And it'll be able to track how fast you're traveling that distance over time. So we added GPS, and like that was cool. Now we can get even more accurate because we're not just attached to the wheels, we're not attached to some mechanism, it's not magnets, it's not even some digital computerized thing internally. It's an external satellite system that actually tracks how fast we're traveling. The next cool thing we did in a car was start using network devices. So we've got an uplink to the internet. So now we can start doing things that are taking all the information we have from inside the car, the speedometer and all of that. We've got the GPS information from outside the car, and we can pull that together and correlate it together. And we can start pulling that information from the internet and as to what we need to know in terms of routes and navigation and all this stuff. So now we're fully networked, not just an in-dash GPS. We're networked so we can get real-time information about other stuff. And the last step, if you've used any of the traffic apps like Waze or whatever, now we're socially sharing how fast I'm driving, where I'm driving. Hey, there's a tire, there's a pothole in the road, there's a policeman over there, person over there, and there's all these different things. There's a gas station, all this stuff that we can see socially interacting with all the information about our speed. And that is how we take a car from absolutely no observability, no monitoring, no information, to very robust idea of observability, because everyone can someone can sit in the back seat with Waze and see how fast we're going. It doesn't have anything to do with the car. It's really pretty wild. So that is the same extension of that metaphor applied to technology in general. So let's think about this. This is really speed, or how fast we're going over time. What if we think about capacity? So another gauge that we came up with in a car long before the speedometer was an actual mechanical float that told us how much gas was in the tank. So how far can we drive? In this car in particular, it looks like the car is off. It doesn't have any gas, but it could tell us what the capacity is. We have calibrated for full and calibrated for empty. If you do that invertly, you could say we're at 0 CPU to 100% CPU. At what point have we run out of that resource? In a car, the resource would be fuel or electricity. If you're I have an electric car. So you could see how much juice you have left. You could also now, in an observability fashion, looking at the capacity of the road you're on, or the throughway you're on, the interstate or the freeway. So you could see whether it's busy or not, what the traffic was, and you could see how many other data points or drivers are out there that are giving you accurate data. Wow, there's a lot of people on my application giving lots of data. It must really be at capacity and drawn in red. I'm going to take an exit in an alternate route and find another way. So we can measure capacity socially and the volume of traffic. We could also look, here's another one for you. Forget the cars for a second. When is the last time you were in an elevator that was jam-packed full of people? And how much weight can there be in an elevator? Have you ever been in an elevator that has one of those little meters on the side that everyone can see, and everyone gets on the elevator and at some point it hits like its maximum weight or within like 90% of its maximum weight? In the old days, a little buzzer would go off, but you couldn't see what the number was. You're just like, what's that buzzer? And so elevators at max capacity. So we have ways of making it observable to the people that are standing in the elevator, and or nowadays, elevators are connected into the security system with a computer, so you could measure the capacity of every elevator trip and see how much energy you're wasting or saving, and or what the safety requirements are. The last one I'll put there for capacity is a bridge. If you think about what civil engineers do, it's really akin to old school system design, which is we have to know the discrete, explicit capacity of every component in the system and break that down. So we're going to use an estimator and a model and then we may actually test it at scale, but we know the tensile strength, we know the shear strength, we know how much concrete, what design for bridge building will work, and we design it so that it will support N amount of cars, N amount of weight. And when it doesn't, horrible tragedies happen. And so what I'm trying to get a point across here is that we have ways in the old school of being an expert in performance, say the performance of a bridge or a system, technology, a computer. And we would know discretely in the model exactly what the capacity is using Little's law on what each of the components discretely could support. And we, as experts, would say, I'm going to design and model and engineer a system that will deliver the end capacity for throughput, for users, for response time, for whatever it is we need. And I have one shot to design it right. And of course, it takes 2.5 years to write that code and deliver it because the world used to move slow. And so you only had one shot. Oddly, you had multiple shots to do that, but we never did that. It was kind of a really archaic model, and we only really relied on that in rocket science and bridge building. Like, there are other things too. If you're building locomotives and weight differentials in inertia. Inertia is really, really terrible in locomotive design. So the idea being, we've moved in technology because of software innovation to do all of these things around the guiding principles that I call the guiding principles for what observability is versus old school logging, monitoring, and the way we used to have to be expert calculators of model-based performance versus observability, meaning real-time views, say in a flame graph, of what is really happening with a system that is operating. So I broke it down into like 5 different guiding principles. The first, the core principle, is visibility. Just make the invisible measurements visual. So what was once, hey, is that concrete in the bridge, is it starting to stress? Well, we don't have any measures. We don't have any way of we don't have any measurements to see whether that actually they can do that, but they didn't in some of these cases. We don't know exactly at the age of the concrete. They make estimations. Again, a lot of calculations, a lot of experts in the corner saying, I'm an expert in concrete and aging concrete and cracks and infrastructure. And so what we're going to try to do is make all of those measurements, those calculations and those understandings and that expertise, just make it visible so that non-experts can start saying, well, I don't have to be an expert to tell you every day at 3 o'clock, we're pushing this bridge a little hard. What do you think of that, right? You could see it. You could see it in a flame graph. You could say, wow, there's a lot more traffic at those times. What's happening to the concrete? What's happening to is it giving? Is the infrastructure there? So visibility is an interesting, powerful concept, which is why you see every tool on the planet. I remember back in the day when LoadRunner first started bringing in actual graphs to visualize the online monitoring. And it was like, wow, that's where we should be headed. And so we started running down the runway as fast as we could that direction. Storability is the next guiding principle. Save those measurements. Of course, if you're going to have measurements and make them visible, of course, you're going to store them. So, and make them usable, stored for calculations in the future, because once you get a sampling, You can do all sorts of interesting projections and calculations and all sorts of things on that sampling to figure out what that data may mean inferred to the real world. Now, that data as well is stored so that you can just rewind 5 minutes and say, in the real world, the system is saturated. So, of course, that's the same kind of thing. Third guiding principle, adjustability. And this is a big difference over kind of the way I've looked at old school logging, monitoring, and kind of the way we manage performance in the past, is that now that we have things that we can see and we can have things that are storable, if I find anomalies, no system is perfect, no profiler is perfect, no, it's an exact clean data. In fact, clean data is just a myth. You think it's clean, but then you're like, well, this is really some weird anomalous thing. We can throw that out. So a lot of the older tools made it almost impossible to just erase or remove some of those measurements. Also, if I'm going to move that data to other systems, which is another guiding principle, making those corrections to any inaccurate measurement or something that was anomalous. So that's a core thing in observability. You can more easily see something that needs to be adjusted. Extensibility, of course. I want to be able to relate the measurements over here to someone else's measurements over there. So to make something observable, I've been in situations where somebody else says, well, I can see this running over here, and I can see the client is doing this information. I can see the network switch is doing that. And I'm like, but I can't see in the database for some reason. Or we didn't turn it on, or we weren't smart enough about logging, or we turned that off because it too much overhead, which is an old problem. So the idea that I need to, and then if I had my monitoring data in format X and all of this information in format Y, how do I get them both to overlay and talk? I do all kinds of, it's just crazy. So having extensibility is a guiding principle for your observability as well. And the last one I want to say is shareability, which is not like technical extensibility, but the ability to communicate those measurements and correlation and causation to other measurements to other people. So for many, many years, it was only that small pool of experts who really knew how to build a bridge and knew concrete, or knew, only the driver in the car knew how fast we were going and never told the person in the passenger seat that we were actually going 85 miles an hour. I did that once on the Autobahn. I think it was over 100 miles an hour on the Autobahn. I'll tell you that story someday. So shareability. And this seems to be almost the most poignant idea of the modern observability movement, is that we are almost absolutely requiring everyone to be collaborative about their work. There are no more, we're going to tear down the silos. We're working in automated pipelines, and we're constantly talking to people on different disciplines. So shareability is core in the idea of, hey, is your system, does it have high observability? A few more comments from some of our industry leaders that I follow. The first one is this whole notion of novelty, which I want to explain for a second. Liz Fong-Jones says the observability, or the observability of the system, must empower us to debug novel cases in production. And novel meaning we didn't know beforehand that we needed to monitor that. Like a bridge, hey, we never foresaw 45 years from now that a car could weigh that much, or we would start using a bridge differently. Concrete's not designed for, everything unravels from that. The idea is, hey, when there are new use cases or new instantiations of something novel in production, I want to have all of the metrics right there. I didn't want to have to predetermine that beforehand. So this idea of novelty is kind of driving some things. Chris Bailey's another one. This is from one of the Observability Con. Can I ask new questions about my system from the outside, understand what's happening on the inside, all without shipping any new code? And I've been in countless systems where we find a performance problem and I want to start digging into it, but then I say, oh, well, can we go back and turn no, you can't go back in production and turn the debug level on, or you can't go back in production and go back in time unless you have a TARDIS, unless you went to Neotys Back to the Future, and then you would put on your red vest and go back. Since you can't do that, the idea is I need to build a system that's efficient enough with all of the observability features enabled, full logging, full monitoring, so that whatever comes along, I can profile it, and I'm not arguing with some sysadmin about, well, there's too much CPU overhead. Well, 3% CPU. Look, things are fairly cheap and we're running in the cloud, just run another instance. Compared to a 6-month lead time and a couple hundreds of thousands of dollars of hardware just to run one more box. I mean, things have changed dramatically in our landscape from a cost optimization perspective. Charity Majors, also from Honeycomb. It's about complex systems, unknown unknowns, meaning it's completely new, emergent behavior, and other hard problems. So observability general, on the general, is just to say, hey, if you built widget X and you built the monitoring for widget X and then you put widget X in production and widget X starts acting differently, or we put something around widget edge and it does something differently, I need to be able to observe that all the time, even when something new and unforeseen happens. I still need to understand it. I still need to fix it. So I thought that was an interesting angle on sort of different from static, old school, just monitor the basics, and I'll talk more about that. A few other thought leaders for you. Paul Sarkowski, I hope I say his name, Sarkowski, I think. Observability is a culture. And we saw this with DevOps as well at the very beginning. Mostly I take that to mean that like DevOps is a culture as in there are reasons some people are sort of moving that direction. Usually it's around collaboration. It's around people just want to operate without biases. And so if it's a cultural thing, it means we just believe some of these guiding principles to be different than maybe the old school way we used to do stuff, which is fine. I love this one from Ronald McCollum. Ronald's from Grafana, a fantastic visualization tool, probably the #1 open source visualization tool at this point. Monitoring is a verb, observability is a noun, and I see that repeated all over the place. But I think he was one of the originators of that. But I love that idea, right? You're going to monitor, observability is a noun, meaning it's a characteristic or quality of the system you built and the system you designed. Is your system observable? Or is it kind of obscure, black box, proprietary, can't be shared, can't be seen, can't be extended, that kind of stuff, right? Thought that was cool. Christine Spang, software is opaque by default, which I agree, it is opaque. Mostly we have words like black box in our industry, and yeah, sure, it can be a black box. It must generate data in order to clue humans in what's going on. Absolutely right. Instrumentation, logging, tracing, everything you see in a flame graph, you bet. You need to be able to do that elegantly. You can't just spit something out and treat it as waste. You actually have to imagine that there's a whole process and some elegance about that. And one of the most controversial ones, I thought, was Peter Alvaro wrote, Twilight of the Experts. As someone who thought maybe I was an expert, maybe, I couldn't agree more. It is. The whole winning thing for a team and for a company is not about me or showing off someone's expertise. That's kind of the old way of thinking things, right? We all get incented mutually if we can share the information and make the most efficient use of everyone's time across the team. And I thought that was really good. So let's talk about unobservable systems because, again, for me, sometimes it's easier to think about something that's not observable so that I can get into the brain of something that is observable. So how many times have you guys diagnosed some kind of a bottleneck? And I'm rolling up my sleeves, putting on the gloves, putting on the jelly, if you will, to reach up into your system and start diagnosing a bottleneck. And suddenly I find, oh, the monitoring was turned off. I mean, that's the worst case. We don't have a speedometer. Forget a fuel gauge. We got nothing. They're not monitoring the system. Oh, that sucks. Monitoring the wrong component. So we have monitoring, but that was for the old version, not the new version running on these servers. Well, how come you didn't turn it on? Well, I don't know. Somebody dropped the ball. Someone missed the thing, and we're doing it manually. Okay, it's monitoring the wrong component. There are no logs. Okay, again, there are no logs, and the monitoring data has gaps, and the log data has gaps. The logging timestamps are wrong, so we've got servers running in different time zones, or this bank of servers runs in UTC, and this runs in the Eastern Pacific time zone. Who knows where the database is? that all sorts of different, so we don't have anything to correlate that to make it easy to understand when something happened. That's really tough. And basically any black box you find. And I'm thinking to myself, I've been in those situations countless times, troubleshooting something in production, troubleshooting something in test prior production if I'm lucky, and I'm still jumping through these flaming hoops of crap just to figure out, hey, can we just make the system more observable? Can we do the default? Like, oh, how can we turn this off? How can we turn that? Why? Well, I don't have permission. It was really interesting. So technical unobservability means you're not doing the basics, monitoring, logging, and then you could turn things on like, are we doing tracing? I would love to have some tracing of that. Do I have a profiling system built in that I could run, one of multiple instances with a profiler on it? What's the overhead of that? Do I have a default trace? Do I have the kernel level trace? So all of those things get coordinated in a way that says, if I have a question, I have some data that might help me find an answer. Inaccuracy. So unobservability due to inaccuracy is another thing that can truncate and make something unobservable. One, aggregation. Countless times we've argued, oh, well, that's an aggregate of an aggregate of an aggregate. So really the 97% CPU spike by that component got averaged out to, well, it's only 63% over the course of 7 days. Oh, thanks. Thanks, APM tool. Love you. That's so old school. And of course, there's someone you'll find in ops who says, oh, I'm only going to run the sampling rate at 15%. Oh, look at that. Limited sampling rate. Well, in test, you can run it for 3 or 5 seconds because you're in test, but in production, that's too much overhead. So we only run, every 5 minutes, we take a CPU sample. Old school, way old school, right? That's like saying, I look at something, I close my eyes for 14 minutes and 58 seconds, and then I open my eyes, and then I close my eyes, and then somebody asks a question, what happened during that 14 minutes? I don't know, my eyes were closed. I mean, it's just idiotic at this point. Why would you ever do that? So you can't be observable just because you have things leading to your assumptions being inaccurate. Extrapolation, we all know extrapolation is evil, but extrapolation is from a mathematical perspective, you're reaching too far. So it's knowing your limits. Maybe you can do small extrapolations, but a lot of people don't put the context. Well, we've extrapolated this by 100x. That's a real problem. Misleading visualizations. So you have complex visualizations. A flame graph, if you're not familiar with it, can look very complex. Grafana has some of the very basic kinds of visualizations. Heat maps are another type of visualization. And depending on how the data gets pulled in to create the visualization, we all know stats can play like crazy. So you can actually mislead people. And are we really observing the truth, or are we seeing some visualization that's not quite accurate? The other thing I'll say is the instrumentation error itself. So somebody did instrument something, and you can see some information, but it's not actually instrumenting the interface that you thought it was. It's not instrumenting proper. We've seen fixes to VMstat over the years, IOstat over the years, as to when the underlying driver topology changed within the kernel. You're not measuring the IOPS per second at the same rate. So you've got differences between tools. So instrumentation itself can have biases or errors, call them errors if you want, in different ways. And that can lead to something. I can observe something, but it's not really, I'm not observing the truth. And the last part of observability I thought about was social unobservability, which means limited people, like the driver is the only one that can see the speedometer. Limited people can see the measurements, which is, again, very like, wow, how many times have you been on a call, especially remotely now? Hey, can you share your screen or shoot me a screenshot? I am an expert in taking screenshots in everything from Snagit to Zing to native print screen, whatever, and throw it in a Slack channel, throw it in Skype, throw it in whatever chat tool, so people can actually see stuff before we had any of the shared dashboards or ability to graph that stuff. Socially unobservable is finger pointing at the experts, where all of a sudden socially we observe something, but we're going to pin it onto one person to see if why didn't they figure it out? Why didn't they know this? Which the point of observability from a guiding principle is to share it and collaborate, not just point fingers at an expert. So people will get scared to share anything socially of what they're observing because they don't want to get the finger pointed at them, or I don't know, I'm the only one that can look at that graph, that kind of behavior, which is fear-based and absolutely anti-productive. Only one person explains everything. So Maria, why don't you get up on the board there and explain everything that we need to know about this versus saying we have the following 4 graphs that we want to walk through and we want to gather everyone's information. So socially, if you kind of force somebody to be accountable for something and explain everything, that one person, it doesn't really work as being, it actually defeats the idea of being observable. We don't mutually learn or understand if we can't socially share and work on that. We can't take other ideas and correlate to them if we build little silos of measurement and we observe things here and I observe things there, but we don't talk to each other. So I can't correlate my data with your data if we can't get along with one another and collaborate. And that means we can't learn from our mistakes and generate new understanding. New understanding would be keying into future observability. So what I'm kind of getting at here is a little bit of a rant, is the old school approach that I kind of grew up with, and understanding that a lot of the people 30 years ago didn't monitor at all. That was old school, right? They set up those monitors according to expertise. I used to get hired, hey, Mark, will you come in and set up our monitoring for Java 3? And how do we monitor? What are the right monitors? And I came in and I'm like, I'm a guru of monitoring X, Y, and Z. And then monitoring .NET. Here are the .NET. Here's the SQL counters you need. Here's the Linux kernel counters you need. And it was all based on my expertise. It wasn't based on, well, what do you guys want to learn? And what do we need to know in order to be successful keeping this thing running in production? A lot of the changes, if there was instrumentation or tracing built in, you had to do it through a config change or code push or something, which was harder to do back then than it is now. And also, if we built all that stuff correctly, I was usually using some proprietary tool, maybe not so much in the Unix world, but some proprietary tool, and the data was kind of stuck in that tool. It could have been a vendor package off the shelf. Open source was not as popular. So it's a very old school idea that, well, you monitored and you got your information with tool X. You stay in tool X. We're the solution to all your problems. Well, not all our problems, just that one. And I couldn't really share it. Maybe there were licensing or training issues. I couldn't actually, I have to take the data out of this tool and put it in this, and then we have to do all these, again, flaming hoops of crap. It also leaned us into a very reactive model for investigation. So we'd set up all the monitoring and let things run, and then when something happened, we better hope that we got all the right information. We'd react to something that was happening. And I contrast that to what I read a lot now about observability, and that meaning instead of not monitoring at all, now we measure all the things all the time, even if we're going to go throw it away. Because truth be told, it costs almost nothing to throw it away, as long as you do that diligently. We're putting almost all of our information either through open telemetry or other open databases that some of them are free. You can pay for the nicer license if you want support and clustering and stuff, but open databases for the measurements to live. And you can put it just about anywhere and get it in and out of those formats, especially time series data, right? Correlating to other measurements. So if you want to correlate those measurements to other measurements, you're in kind of an open database where you can do that. It's refinable, meaning you usually have access to the raw data. You could say, that is a glitch, and we're going to fill that in with the right data, and we're going to put a note or a tag on that says this was, manually manipulated. You could change data. You can add data. We're missing that 5 minutes. Let's put in 5 minutes from the other system, transform that data, and put it into place for our graphing. Observability, again, everyone and anyone can see. Almost all of the companies I've been at for nearly 10 years have some kind of information radiator with big monitors all over the place. Also through your computer, you can get to those websites and see, even if it's read-only, you can see the graphs, what's currently happening in production. It's usually running everywhere. A shout out to John Alspaw many years ago, if it moves, graph it, have a nice day. It's a different attitude. And then I'm finding all of those principles lean towards a more proactive model for investigation, because even though something's not going haywire now in production, we can start seeing trends and say, that looks peculiar, that's weird, why is that? We're doing a lot of strange class loading there, why are we doing that? That's very interesting. And so you could be more proactive about your investigations and your experimentation to figure out, hey, what does this mean? How do we understand our system at that point? So when it comes to designing a system and engineering a system for observability, that's where it came to me. It's like if I'm advising people on architecture and how sitting in a code review, or I'm helping people go through stuff, I came up with a very lengthy way of saying this, which is your overall goal is to enable other people to see everything going on inside your application using tools from the outside of your application, shout out to Chris Bailey, without having to stop the system, reconfigure some tool, or recreate the original problem they were trying to understand and solve, which means no repros, no nothing. Your goal is to design a system whereby it's constantly informing everyone around you, every other tool it depends on. I'm constantly sending information. Tools, then I think your system becomes kind of narcissistic. It just talks about itself all the time, just spits all that information out. In short, the goal is actually make it really easy to operate your application, where the definition of easy is I don't have to do extra steps because we're doing something stupid, and operate meaning I can easily see what I need to do, take actions to keep a system running. So, engineering for visibility, visibility being key. So I came up with the following list. Exposing information about the application means timestamps on every action, durations on remote calls, meaning how much time spent, volumes on things that impact capacity, how many bytes came to and from. Network capacity is a really good one. Memory, how big are the objects flushing through cache. List methods and constructors. So if you actually spin up an object, log out, hey, these are the current methods and construct. I mean, you don't have to open a debugger, extra profiler, extra trace stuff. You could just say every time I'm instantiated, I kind of tell everyone, hey, I showed up at the party and these are my 16 constructors and methods. We're all at the party and you don't have to ask questions. Spit out your version information. I mean, there's all sorts of things you can do in very lightweight text. If you're in an event-driven architecture, sort of consumer, publisher, producer, consumer kind of model, entries and exits. So every time a message enters, every time it exits, who put it on the stack, who took it off the stack. So event-driven information is high throughput and also really, really information over time, good information over time. Use an instrumentation framework. Look at some of the others. The Honeycomb stuff is interesting, but also you've got ETW frameworks and other things in the Java and Python world. Node and React also have some interesting instrumentation frameworks that can work as well. And then expose what's important to this app. If you're just one component amongst everything, expose what's information is interesting. If anyone comes talking about me, my little component, I need to give tons of information about why I exist, why I'm running, who I'm talking to, all that kind of information. So interrogation is easy. So make things visible, and that's the 90% of the battle. I have an acronym for you, and I'm going to keep moving pretty quick here. I know we're running close on time, but I'm going to try to keep it going. It's being recorded, so you can go back and watch it. Logs should be dumb, and an acronym is dumb. Logging is dumb, but logs should be dumb. D for dumb, debug mode should not be required on normal operation of the code in production, meaning you should require no change to the logging level in order to operate the application. The log should be dumb. Debug mode not required. Normal logging has everything we need in it. Universally available, the U of dumb, universally available in a simple log format, meaning no special tools, no transformation, not shoved somewhere in a weird thing. Make it universally available so that anyone can access, or any tool can access and see those log messages and pull them out. M, manageable. We all know logging, things get huge, right? So think about it for the long term. Is it manageable over the long term now that we're adding more observation information into those logs? What's the size? What's the storage? What's the archiving? If I'm building a system, I want to make sure, all right, this thing is going to create 10 megabytes per second of logs. Where are we going to put them? How do they live? Let's do this so that we don't create overhead on the system that's running and needs that resource. Let's figure out how to do that asynchronously, which in industry-wise is a solved problem. And then B, your log should be business relevant, meaning to all viewers, this is the challenge. If I log something, I should have information in there that says, here's why this event matters. user was not able to open account. So you have a log message, error 6, ACCT-102 error 6, blah, 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 comma, user was unable to open their account profile page 3. Like the business needs to be able to, because a lot of these log messages show up in emails and they show up in presentations in front of a whatever. And suddenly there's a business person that pays your paycheck and pays my paycheck. And they're like, well, why is that log message important? Oh, because 92% of our users for that 3-minute window were unable to open their profiles. Oh, that's a major issue. Let's go fix that. So dumb, make your logs dumb. Monitoring all the things, this is pretty simple, right? We know to monitor time. So we're pretty good about monitoring time spent doing everything from the front end to methods in the middle tier, messaging, database calls, queries, you name it, I/O. Physical resources, again, all the stuff we've already done. CPU, disk memory, network power, cooling, kind of the run-of-the-mill basic stuff. You got to have that bread and butter. Logical resources, this is one that people miss out on, but now this is bread and butter. Connections, threads, objects, rows. Really anything that's governed by software, min-max configuration or maximum capable number of threads, number of connections, number of IP addresses, number of sockets, whatever that is, logical resource usage. Access, meaning log information, monitor access. How many sessions were created? How many calls per second? How many instances of a virtual machine? Instances of a component? Instances of an object? Paths. So how many different paths do we have in play? And does that change? Sockets, anything from the network stack you could put in there. And then I start going into thinking monitor volume, right? Number of users, transactions, third-party calls, anything related to the amount of activity happening on the system. And the last one I throw in, which is a classic APM thing, it's the hardest one to do, is to try to figure out transactionally, functionally, and as well as resource, what are the hard or soft costs to do that? Physically, what do we pay to run a Lambda function and number of times a second? We can probably quantify that from a financial perspective. We bought a large SAN. It does n number of database calls per second. Here's the number of inserts. Here's the size of the inserts. We can start making financial guesstimations, I'll say, or observe the financial aspect if we can connect them somehow to the basics of all these other monitoring pieces. The last one is monitoring sentiment. We see this a little bit in some of the monitoring tools that look at frustration and the scoring. Indirectly or inferred, computed through response time, the thresholds you build into your frustration model, if you will, or direct human feedback. So if you can see the number of dislikes or unfollows or spam you're getting on Twitter at the same time you go through an outage, believe me, every modern ops person observing things says, well, we had a little glitch, but it wasn't that little because it was a really sensitive part of the application and everyone's upset. Versus we had a major glitch on something that nobody gives a shit about, so no sentiment is just fine, not affected. So think about the emotional sentiment to customers at that point. Tracing in systems, this is a key part you'll find in observability. I'm not going to go into depth on this. There's some other experts that do this really well. But one of the ideas behind observability, if you're engineering a system, is making sure it's able to be traced, not only from the kernel, but also into your stack itself via trace IDs. And trace IDs are something you propagate across the entire componentry. And that includes both the parents and the state that are being sent. So if you have a component in the middle of a call, it can trace around it, so to speak. And you're really looking at including the usage, the volume, the session information itself for that trace. It might include cost information, transactional cost information or not, but it's definitely seeing the world in an internet-connected way. Old school tracing systems used to throw an ID in a header, but the first component it hit, it can't trace beyond that. It was who knew. Now we have more ubiquitous, the open telemetry stuff that does a better job of this. There's a couple of good Dynatrace stuff on that. Instrumentation, the key things I'll say here, you need to keep in mind that manually adding instrumentation, your devs are probably already using log framework of some kind, but that logging and event tracing has nowadays very, very low overhead compared to 10 years ago, 5 years ago. It takes time to code that, but it saves tons of time for everyone else downstream in the process. And if you have to pull a dev into production to troubleshoot something, they're familiar with the information that they've logged out. Looking at automated instrumentation and profiling is obviously much easier, but you sort of are disconnected potentially from the development team. So if you auto instrument with a profiler in production, but they don't know that profiler, they don't know what the format looks like, you still have some distance between you. Instrumenting in and out and around third-party stuff, and be explicit in instrumentation about the context for each call as to why something was instantiated and why it's calling. And I'm going to give a shout out to Dynatrace. They have an ebook, our mutual friend Dynatrace, automating the whole process. There are 4 areas of automation that they came up with in a very short ebook around observability. There's a couple, I think Andy may have some talks on this. Auto discovery, auto instrumentation, auto baselining, and auto updates, which basically removes all of the painful headaches and like dumb gotchas, trip on your own shoelaces to observability in the Dynatrace platform itself. And so that's kind of the idea. So check out platform observability under the Dynatrace world, and there's some interesting ideas in there as well. Let me cruise through the last section. I know I have just a few minutes, and then we'll keep going there. 3 things around socialization for performance that makes this observability thing so popular. 1, there's a backlash against unintelligent, lazy, static monitoring and logging. That's the sentiment in the community. Absolutely agree with them. If you're being lazy or not so smart about static old monitoring approaches, you deserve to get bit in production by some new bug that you didn't know was going to happen. It's adopting open source and open standards and sharing of information. So part of the idea that we're going to be completely open about this and not stuck in a proprietary system. And again, there's this preference for collaboration across the team versus solo silos of expertise. So those 3 main ideas brought me to want to share just a few last steps here, last concepts, ideas with you. We all know about correlation and causation. In the greater world, if you've ever been under fire from your management or VP or executives, they want to know the root cause. They want to know what actually caused the failure. They might want to know what else happened when we failed that's correlated to that, potentially. But the real thing is we want to know a cause. We want to know if we can fix what caused it, maybe. And we want to know other information that can help. And we want to know some percentage of certainty around causation. So the question being, how much time do you spend on correlation? And if you're drowning in correlation, do you feel like you're losing the attention of your stakeholders, right? Do you feel like, I'm just talking about stuff that happened around the same time, unlike a flame graph where you could be like, all right, this seems to be very related or very cogent to what I'm talking about. So prioritize causation over correlation and think about correlation in terms of data to support your causation. Observability is about making that almost instantaneous, very easy. Observation is different than troubleshooting in the following ways. Observation relates to making things seeable. So it enables rapid learning, now that we can see it, and minimal misunderstanding because everyone sees the same speedometer, the same graph. It supports a process for action, reaction, investigation, and escalation. So you can use the same data, the same observations through that whole process. And it's expandable to a larger audience, right? That larger audience that's brought in to help. Troubleshooting or problem solving, problem isolation, is really focused on remediation and validation of a fix, right? It's enabled based on the observations, low risk with high confidence. So I know those observations, this is the thing to fix, I have causation. It has a process enabled to repeat the incident, maybe, and compare to an erroneous state. So we can actually prove that we fixed it. And then it derives new coding patterns potentially. Hey, let's not make the same mistake, go back into the code base and fix this problem we found wherever we did it. The other part of performance socialization is a culture of performance, which is teamwork and collaboration. And I'll say, as a guy who's worked in many different capacities in performance in my day, you need to be inclusive in the performance world. because there's so many other people that know new stuff that you don't know and know stuff that they have never shared because they didn't know they had to share it. So fostering some curiosity about performance, sorry, this is out of order, sharing accountability for fixes, enabling other people to see and learn, making it safe to be seen as the root cause. If I actually made the mistake, my bad, I'll fix that code. And then also sharing the rewards for optimization. So if together as a team, we actually optimize something, got something working, let's give ourselves a reward each other. And that's an important part of the process. But that makes a culture of performance, very positive social aspect to how we do the work. In summary, just to go over those 4 areas again, when it comes to observing performance, it's not just monitoring and logging as usual. Things are evolving. They have been evolving for a while. Think about the unobservable systems that you've dealt with, right? We've always struggled with them. They suck time and energy. It's horrible. When it comes to building system or advising people on their design and engineering and architecture, building your systems, first and foremost, trace and log everything and make it visible. Everything else will follow from that. And then when it comes to building a performance culture, breaking down those silos, use the observability and the visualization capabilities to break that stuff down and break it apart and start collaborating on stuff. And that's with 3 minutes left. Thank you very much. Look at that look at that slide. It's even got the shoes on there, Henry.
Gosh, I don't have those shoes, by the way. So yeah, you almost hit the buzz. I was going to press on the button like. You were very, 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 very close, you know.
Almost to the buzzer.
Yeah. So I think. Okay, so we have 3 minutes left. Is there any questions related? So we have 3 minutes before we I give the stage to Patrick. Scott, I saw that you were interacting. So let me maybe, I don't know if you're still up.
Hey, how's it going?
Yeah, you are. And up. Oh, you're in the office now. You changed.
I am. I've decided to move places and put on a headset and stuff like that.
Okay.
Fantastic presentation, and it's I think it resonates with a lot of the stuff I've learned over the last 14 years. It's I used to just look at some very coarse-grained monitoring, and the CPU's gone up, and that's all very well and good. One of the things I've found quite often, particularly over the last couple of years, is you have a developer or a sysadmin or the guy who looks after the server, and they know that they have all of these logs here, but they won't actually let you look at them because they have this mindset that, well, if I can't find a way to go through 3 gigs of logs and find something, therefore absolutely nobody else can as well, so you're not going to have them, and I can't be bothered figuring out how to get them to you because it's just all too complex and things like that. And there's a little bit of challenge and working to try and break that mindset. It's very rewarding when you do, and particularly when you find where you've got the soft logs, you've got the application logs, and you have the performance logs, your traditional metrics and stuff like that. Yeah. And then you can start at one point, trace a transaction through from system to system to system. Usually I've got a piece of paper and a pen next to me, and I do it manually first, and then a Perl script appears, and then the whole lot becomes automated from there. But it's a fantastic skill to learn, and I wish more people in the industry would actually take time and get into the observability part and start digging and finding things out rather than just relying on APM or just relying on what the test tool is telling you.
Yeah, I think, Scott, the thing is, like, those struggles are not new, but the way a newer generation or the observability community talks about those struggles is as if they can't believe that anyone would be that database person. Like, you are basically working against the company or the organization we're working for, and it's almost like it's like disbelief. Like, why are you even working here? Like, it's that different compared to the same thing. 10 years ago, you're like, every DBA is just like that.
Yeah, and then I think one of the points you touched on as well is it's often I refer to it as the tyranny of aggregation.
Yeah.
So yeah, I've worked in one system where I know it was taking 30 seconds to log in because I was logging in and I had a stopwatch, and my colleague was logging in and he had a stopwatch, but the system guy said, no, it's only taking 1.5 seconds. And the reason it was taking 1.5 seconds, and it did on average take 1.5 seconds when you aggregate it over 10 minutes. So
Yeah.
absolutely 100% statistically correct and totally useless at the same time.
Yeah. At all. Yeah.
None at all. None at all.
Awesome. Groovy. Thank you, Scott.